In 3f, this is another example of a polynomial divided by a monomial. It's just disguised a little bit. I've got 5x to the fourth, y squared minus 10xy minus 25x squared y to the fifth. Now that's times, or we're multiplying it times, this 5x squared y squared to the negative 1, which if we apply our rule for a negative exponent, it becomes 1 over 5x squared y squared. So this is simply a division problem written a little bit differently. By putting that negative 1 as a power, it becomes something over, or 1 over something, and this is over 1. So if you wanted to think of it, you either are distributing this fraction of 1 over 5x squared y squared, or you're just distributing your division. So it's 5x to the fourth y squared divided by 5x squared y squared, then minus 10xy divided by your 5x squared y squared, then minus 25x squared y to the fifth, all over 5x squared y squared. So then it takes on a lot of the same nature as we had in the previous problem. We'll come back to each monomial and reduce. 5 divided by 5 is 1. There are more x's in the top than the bottom. There's 2 more of them, so it's x squared, or we can use our quotient rule. And then the y squared is reduced to a factor of 1. So all I have is x squared there. On the next one, it's 10 divided by 5. So this 10 divided by 5 is negative 2. We have an x divided by x squared. Now I have more x's on the bottom than the top, so I want to make sure I have more x's on the bottom than the top. There's one more. I have one more y on the bottom than the top, so that is a y. I'll come back and show you a different technique that some people were doing, and it's exactly the same. Then minus, and 25 divided by 5 gives you a 5, and then our x squared is reduced, and I have 3 more y's on the top and the bottom, which is y to the third. Okay, so I said I'd come back and talk a little bit more about what we did here. Many people in this problem were wanting to take it, so I'm just going to pull this out and bubble it at a negative 10xy all over 5x squared y squared. So if you apply your rules as we do with monomials, then this 5 goes into negative 10, negative 2 times. Then we start subtracting our exponents. It's x to the first minus x to the second. So 1 minus 2 is x to the negative 1. And the same thing with this, it's y minus 2, or y to the first divided by y to the second, which is y to the 1 minus 2, which is negative 1. But you can't, what we're not supposed to do is we're not supposed to leave negative exponents in simplest form. So what I got to do is do one more conversion to this. This is going to be negative 2. If it's negative in the numerator, then you put it down in the denominator because you're going to reciprocate that base. So if it's in the numerator, it'll end up in the denominator to the first. And the same thing with that y, it'll end up down here at the denominator as well. So same result, maybe a little different technique, but equally correct.